Okay, so what is PIB Dev? PIB stands for Pilot in a Box. So this is something that the Azure Product Group is working on in conjunction with Microsoft's Commercial Software Engineering, which is an arm inside of Microsoft that does really advanced engineering work on early adoption stuff with the product groups. So for right now, if you go to github.com, Kubernetes 101, pibdev, this is a public repo. So if you have GitHub Codespaces access, you can actually click use this as a template and deploy it into your own GitHub repository and start working. The workshop that we have going on is actually adding in your GitHub ID into their repo, so that way they are hosting the code space for you and paying for those charges. So that's what our workshop is about. But at a high level, what is Pilot in a Box? And so if you kind of scroll down a little bit here, what you'll see, there's a nice little diagram in the Interloop Lab 1, which shows you what's really going on in GitHub Codespaces. So as you can see, what GitHub Codespaces is a development environment in the cloud hosted by GitHub, and it's in a container. And what they do with their code space is they already put, with the dev container, they actually go install and pre-build a container that has a bunch of development tools that you're used to today if you're used to Kubernetes. So, you know, all your Kubernetes tools, K9s, a bunch of other tooling. They also, when you go build the app and go deploy it, they also use a lot of the out-of-the-box CNCF tools. So they actually go spin up Fluentbit, Prometheus, Grafana. They actually spin up a local container registry. And then when you're deploying your application, they actually use the upstream Flux v2 so to go run everything. And then they also use GitHub's node ports to go forward ports from your container running in the cloud to your local machine, so that when you can actually have something on the network, or you can go do testing from your machine that talks to the stuff that's sitting in the cloud. So you know, what does that kind of look like all up? So I kind of wanted to explain this a bit, because this is a little bit different way of doing things. Instead of a push model of CI/CD pipelines taking code from repositories and pushing it into things, Flux means you're pulling stuff from Git repositories and then doing a reconciliation on the cluster to get to kind of your desired state that was defined. So what you can see here, so we've got the Git repo. You can think of this as the Kubernetes 101, pib dev, or if you forked it into your own repo using it as a template, that's what that would be. So when you are in that repo and you come in here and you say, you know, go ahead and create a code space, or use this template on yours and then create a code space. When you click on that, you will see something like this, which looks just like Visual Studio Code in the browser. And so here, this is my code space that's up and running. So, you know, it is this thing right here. It already has all of these things deployed to it, a local K3D cluster. I've already deployed the My App sample app to it. And so what you can see here is that even though this is sitting in the cloud, I've got a bunch of local ports forwarded, so I can go see the app. They, out of the box default, provide a .NET Core Web API and a Java Web API as templates. And then you can also see we've got our Grafana dashboard, and then our Prometheus for doing actually querying on the logs and things like that. And so you can go configure these things for the logs. For example, you can go configure Fluentbit to send things up to Azure Log Analytics and other things. So what the workshop that we'll be doing, workshop number 1 is really walking through getting access to this Git repo, and then going and saying, hey, I'd like a code space, and configuring that. Code spaces allows you to go up to like 32 core, 256 gigs of RAM, and just very high power things if you want to do a lot of things. And then deploying a sample app called My App. So, you know, creating and deploying that application, seeing it running. That's what you can see here. This is My App. And then once it's running, going through and understanding how Prometheus and Grafana and Fluentbit work. And then lab 2 is actually taking, and instead of, you know, going and building the code and deploying it up and pushing it to the local container and then kind of going and deploying it back onto the local cluster, lab number 2 is basically saying, okay, let's go put Flux on this K3D cluster and then have Flux go look at a source, which is a combination of a branch and a repository that Flux monitors every minute and looks for changes. And then when it sees changes, it says, hey, it takes those changes, pulls that down, and then does a reconciliation. If there are new container images, new customized files, that will go and say, these are the configurations that I need to go deploy into my cluster. And then the labs 3, 4, 5, and afterwards, which you can go back and look at on pibdev here, you can go see the follow-on labs that they have. 3 and 4 are ring-based deployments. So basically saying, hey, if I've got a bunch of clusters, let's say maybe all of these are US East, and maybe some state, and they pertain to some retail store, you can go basically say, hey, I want retail stores in East as part of like a certain ring. You might say, I want a store in each region, and you've configured those to be another ring. So you can kind of go set up canary type clusters and configurations and say, I want to deploy maybe a new version, maybe 1.2 of my application into those canary cluster rings. And so that's really what you're looking at when you're starting to do ring-based deployments. So you can gradually roll out to larger things. Lab number 4 will actually help you set up an Azure subscription in Codespaces. And so what this will allow you to do is all of these Kubernetes clusters here, you can spin them up in Azure. So you can go quite easily create a resource group in Azure and go spin up 50 or 100 Kubernetes clusters if you want. Just make sure you delete them afterwards so you don't forget about them. And then go configure those and set them up how you want. And then some of the more advanced labs that they are in various stages, and they will be finishing this up here shortly, are Arc-enabled GitOps. So that's the one I just talked about. Using Flagger to experiment with Canary stuff. They have some examples for Vision on Edge. So if you think of where you may have an edge cluster that has a GPU on it, maybe an Azure Stack Edge Pro 2 or a Dell box that has a GPU in it, to do Vision on Edge. So that's another one that they've got there. The Centralized Observability Lab is really looking at how do you go manage a fleet of Kubernetes clusters, and how do you build dashboards and things like that allow you to say regions, clusters, how's my health, things like that. And then the last couple here are Outer Loop with AKS IoT. This is actually, if you want to see a video of this, Project Haven Microsoft. I will put this link in here. This is actually basically taking AKS and going and deploying it on any Windows 10 or 11 device. And so that's a very powerful thing that is coming out here, much more highly available at Microsoft Ignite here in about another week. So this will allow you to go essentially take AKS, Arc-enabled AKS, and go deploy it onto an edge window, a fanless Windows 10 or 11 device in a manufacturing, retail, things like that, and then Arc-enabled GitOps. AKS IoT also supports single node and multi-node clusters for high availability. So if you think of the classical, I'm a customer, retail, or manufacturing location, and I want to deploy 2 or 3 Intel NUCs, that's the scenario they're targeting here. And then the last couple of pieces here are deploying to an AKS cluster with Arc-enabled GitOps. And then they also have some things that they're working on for deploying to like GKE, EKS Anywhere, Tanzu clusters, and other things. In the CSE labs that they've been doing a lot of this work in, they're up to hundreds of clusters among a bunch of different types of Kubernetes deployments and ingress controllers and other things using Kustomize to go configure all those kind of things. So that's what pibdev, pilot in a box dev, really means. It is inner and outer loop developing applications in Kubernetes and making it easy. The other part that is part of this lab that isn't highlighted too heavily here but is also really interesting is the fleet management APIs. And so the fleet management APIs, which you will go do in the outer loop labs, allows you to go execute a series of commands against a set of clusters. So using a single command, you can actually go execute a bunch of shell scripts or a bunch of commands against a whole bunch of clusters and return those results in aggregate and do a bunch of really cool things. All of the tooling that the Microsoft teams have built for Kik, that's Kubernetes in code spaces, in Flux, you can do a -- show on for the most part and see the underlying Kubernetes raw commands that are executed. So it's really useful for inner and outer loop development, training, learning. And then all of the fleet management stuff that you'll see in the labs is getting rolled into the Azure Arc product itself. So at some point here, you'll see, AZ Arc commands that actually are the fleet commands. So a lot of the concepts here will roll into the production Arc stuff here before too long. So thanks, and happy and have a lot of fun in your hackathons.